there, it's Katie with TutorPug, and I want to do a little quick demonstration of how to calculate the standard deviation and the variance for specifically using some COMM stats formulas. Different focuses of statistics will use different formulas. They're calculating the same thing, the concept is the same, but sometimes we just go about it a different way depending on what we have available to us in terms of numbers to analyze. So if you don't understand the concept of standard deviation or variability or spread or a measure of center, go watch my other video that talks about those conceptually, and then this is how to actually calculate them. So I'm going to start over here, which is using the COMM stat formula for variance. We'll start with variance when we know the sample mean, or if the problem has already given us the sample mean. So let's say that I go to a team of female gymnasts, and I'm going to take a sample of those gymnasts. I'm going to pick 5 of them. I'm going to randomly sample them, and I'm going to weigh each one of them. So gymnast number 1 weighs 121, gymnast number 2 weighs 115. So I record all of their weights, and my handy dandy neighborhood statistician has already calculated their sample mean weight, or their average weight. So if we add all of these up and divide by the number of gymnasts, which is 5, that gives me an average or a mean weight of 118 pounds. And that X bar, that symbol right there, is very important. It indicates that this number represents an average or a mean, and it's a mean that came from a sample, not a population. If this was a mean that was representing something from a population, I would use that symbol mu, which is something that's very basic and straightforward. So if I'm given a problem where I know what everybody's individual weights are, or everybody's individual values, and I already have the sample mean, I can use this formula. And the way this guy works, it looks very intimidating. It's got, some Greek symbols and some things you don't worry, and squared, and oh my gosh, we're dividing, and it's all over the map. But it's very simple, and it follows the order of operations. So as soon as you know how the little pieces work, they're no problem. So this first part says, we've got to start here in the parentheses, and this says, from each individual weight, I'm going to subtract the mean. So if I do that, I'll make that as a new column, and let's call that X minus X bar. So that means that I'm going to take this value, X just means each individual subject's value for that variable. So in this case, each individual gymnast's weight. The variable is that I'm measuring is the weight. So here I'm going to take 121, that's girl number 1's weight, and I'm going to subtract 118. Your weight minus the mean, okay, 121 minus 18 is 3. 115 minus 118 is negative 3. 118 minus 118 is 0. That's okay. These things can be 0. They can be positive, they can be negative. We'll fix it in the end. This is fine. 125 minus 118 is 7, and 111 minus 118 is negative 7. So all I've done is this piece inside the parentheses. Okay, now order of operations says, if you remember PEMDAS, please excuse my dirty athletic socks, PEMDAS, order of operations, parentheses first, check, did it. E, exponent. Now we have to take care of the exponents. So once we get these numbers, now we're going to square each one of them. Okay, 3 squared is 9. Negative 3 squared is 9. Negative 3 times negative 3, positive 9. 0 squared is 0. 7 squared is 49. Negative 7 squared is 49. Easy enough. So I did this part, my parentheses. I did my exponent. Now the next in line is this sigma symbol, this big Greek letter sigma, which in the world of math, in the world of Excel, in the world of statistics, it means add or sum, sigma for sum. And it simply says, find the sum or add up all of those numbers. So I'm going to add up this column. And it's early in the morning, so I'm going to use my calculator. Normally, I get 116. So the sum of all those, the sum of this is 116. So now I have this entire numerator. I just figured out the number that's the whole top. So that is 116. Now I'm going to divide it by n minus 1. And n represents the number of individuals in my sample. How many gymnasts did I weigh? Well, I weighed 5 different gymnasts. That's how many were in my sample. So 5 minus 1 is 4. So if I do 116 divided by 4, I get 29. I'm going to get a number. That's all this is I'm just calculating a number, and then I'm going to interpret what that number means according to the other video that talks about the concept of variability and standard deviation. So this number represents the variance. This whole thing could be or is denoted by S squared. S, Roman letter, American English letter S, means it came from the sample. The fact that it's squared means that this is the variance. Now if I want to take the standard deviation, I simply take the square root of that. So the standard deviation, which is just S, not squared, just S, is the square root of the variance. So in this case, it's the square root of 29, which is 5 and change, 5.385. So I went to the gymnastics team, I grabbed 5 girls. I weighed each one of them. I wanted to know, what's the general middle weight? What's the measure of center, the mean? The general average, the mean weight is 118 pounds with a standard deviation of 5.385 pounds, which tells me that on average, each girl is different or varying from the average by this many pounds. When your standard deviation number is relatively small, that tells you that everybody in the data set is similar to each other based on the variable you're measuring. So if you think about a gymnastics team, they're all built very similarly in terms of weight or height or body style. They're smaller, muscular, very low body fat. They're phenomenal athletes. And it takes a certain... Individuals of a certain body style tend to succeed more at this particular sport, and that body style has a generally lower weight. And everybody on the team is a generally lower weight. So I would imagine that my standard deviation would be small, because that tells me that with relation to the mean, with relation to the center, each individual girl is kind of clumped around that mean. I don't have girls that are 200 pounds and 50 pounds and 160 pounds. Everybody's real close to the mean. That's a small variance. People don't vary much from the mean or the center, which also means a small standard deviation. So that's how you calculate this if you are given or know or can calculate the sample mean, and it's just really convenient to use this formula. Well, what if we have a data set or a homework problem or a test question where we don't have the mean? We don't have that mean, and maybe we don't have the ability to calculate it, or we're told that we have to use the formula where we do not get to incorporate the sample mean. So that's this different formula. Again, it looks intimidating. Don't be scared. It's order of operations, and everything you need is right there in the problem. So the way this guy breaks down is I'm going to make some columns and I'm going to fill in these blanks. And now I've weighed some mice and I've recorded their weight in ounces. I'm really not entirely sure what a mouse weighs. I used to know, but it's been a while. So let's get this a little closer. So this says, first of all, I'm going to take each individual weight and square it first. So let's just go ahead and do that. Okay. I'm going to make a column that is each individual value squared. And I'm working with the values of the variable. This is just an identifier. Hey, which mouse are you? I'm mouse number 3. I don't care what mouse you are. I care how much you weigh. So I'm going to square the weights. Okay, 3 squared is 9, 4, 25, 16, and 4. Boom, 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 square, square, square. Then this piece says, okay, after you have squared them, now add them up. All right, so the sum of this column is 58. So this value right here is 58. That's what that number is going to turn out to be. Okay, now I have to do this set of operations, and notice how now the sigma symbol is in the parentheses. PEMDAS, you still have to do parentheses first. So I have to follow the rules of the sigma instructions first, and then I do the exponents. So this notation says first add up all of the mouse weights, and after you've done that, then square that number. So here are my mouse weights, just my regular old mouse weights, not squared. So I'm going to sum those. 3, 2, 5, 4, 2 is 16, I think. Yeah. So this says first add it up, now square that number. 16 squared is 256. And that portion is going to be divided by n, the number of mice we have. 1, 2, 3, 4, 5 mices. So this number turns into 58. This chunk turns into 256 divided by 5. And so I'll do that math, and then I'm going to multiply it by 1 divided by 4. This would be the number 4 because n is how many mice I have, minus 1, 5 minus 1 is 4. So the math that I'll be doing is 1 over 4, sitting out in the front, times 58 minus 256 over 5. It broke down pretty nicely. Okay, so if I do 256 divided by 5, that gives me 58 minus 51.2, and 58 minus 51.2 is 6.8, and now I could either multiply 6.8 times 1/4, or I could do 6.8 divided by 4. Same exact set of instructions or math. So this represents, again, no big square root signs, so this represents the variance. And if I take the square root of both sides, I get the standard deviation. I'll round it to 3. So I still don't know what my average mouse weight is. I was able to circumvent that or get around that by using this formula, which does not make use of the sample mean. It just makes use of the individual values of the variable. So hopefully that sort of explains how those formulas work. Again, try not to be intimidated. They look intimidating. It looks Greek. There's a Greek letter, but it's following the order of operations. And sigma always means sum or add up. And sometimes you do an activity first and then sum. Or sometimes you sum or add up first and then do the activity. So the key is to watch for where the parentheses occur. Happy mathing, and check out my other video on how to conceptually understand standard deviation, measures of center, measures of spread, things like that.